Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 54 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Elite Explorer Kit. Now, hopefully most of you guys already have your gear, but if you don't, take a look. Down in the description, there is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what we're going to do is we are going to build a portable distance measurement system based on the ultrasonic sensor HC-SR04, and then it's going to be completely portable, meaning that we will display our measured distance using the SSD1306 OLED. Now, this is actually the solution to the homework assignment that I gave you in lesson number 53. So I must ask, how many of you were successful? If you were successful, leave a comment down below. I am legend, double chest bump. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. But never fear, I'm going to show you my solution. I will show you how to hook the circuit up. I will show you how to code it. I'll show you how to do the calculations. We're going to do the whole thing today. Now, I'm going to go a little bit fast through the parts on the HC-SR04 because I just did a lesson on that. Lesson number 52 in this series, I showed you how to use the ultrasonic sensor. And then lesson number 53, I showed you how to do the SSD1306 OLED, the little display. So if you feel I'm going a little fast, you can go back and review those two lessons, and then you should feel very comfortable with the things that I am doing today. Okay, so enough of all this introductory banter. Let's jump in and see if we can get busy. I think I got a boat back there. Let me get out of your way. Oops, yeah, we just missed him. Behind the palm tree, he just went back. Another boat up there in the corner. So the fishermen are out in force today, but I digress. All right, so let me just kind of show you an overview of the project. This is what my project build, just love looking at the fishermen, but this is what my project build looks like. Okay, and so we want it to be portable, and because we want it to be portable, we're going to need a power supply. So I am using this battery power supply, which is in the Sunfounder kit, and so that plugs into the board, and you can make sure that that's in there well. So I've got the power supply. Then I have the SSD1306 OLED. I have the HC-SR04 Ultrasonic Sensor. I have a Go button, and then I have the Arduino. And then I've got this all hooked up such that after I download the code, the whole project can be completely portable. You can walk around and make measurements without having any wire at all attached. And so that is what we are going to learn today. Never fear, you're not going to have to try to figure out how I hooked this thing up from this mess here, because if you go over and open a browser and you go to the most excellent www.toptechboy.com, and then what I will need you to do is I will need you to search on, with this happy little search icon here or this Google search bar, search on something like Arduino project for a portable ultrasonic distance sensor. Okay, and then if you come down here and click on this image, you'll have the schematic, and we've already hooked these things up, and so it should be fairly straightforward to hook this thing up. But what I can tell you, just as we're looking at this, that we are going to be using a pull-up resistor on our button pin, on our go pin, our push button. And so we have the right leg connected to digital pin 2, and we've got the left leg connected to ground. And then what I can say is that we will use an internal pull-up resistor. We will activate the pull-up resistor inside the Arduino. So that's the push button. And then on the HC-SR04, the left leg VCC goes to the power rail down here, and then the trig pin, which is the second pin, it is going to go over to pin 4, digital pin 4, and then the echo pin, which is the third pin, is going to go to digital pin 3, and then ground, the fourth pin, goes to ground. Ground goes to ground, VCC goes to VCC. Now, what establishes those grounded VCC rails? It is the power module over here with the little battery. And just make sure that you notice the plus pin is labeled plus. You see that plus? Do you see that plus there? That plus makes this one the power rail, and this minus makes this bottom one the ground rail. You can see up here, this is also a power rail, and this is also a ground rail. What I can also say, as we look at this, we always want to make sure the jumper pins are in the right position. If the jumper is on the center 2 pins, it deactivates those pins. So if we put it center and center with the jumpers, then no voltage will go to those output pins. All right. And that's how we always want to put it back in the kit. Always put it back to the 0 volt position so you couldn't inadvertently short something out when you throw it back in your kit. Also, make sure that you plug the device back into the foam to cover those pins up so you couldn't have an inadvertent short. And then also make sure when you put it away that you set it to off. So you don't want to just casually walk around with a LiPo battery in your pocket or casually have a LiPo battery sitting in your kit. You always want to be cognizant anytime you use any form of LiPo battery to make sure that you're not going to allow that battery to short out. And so that is what I will tell you every time that we use this thing. But with that aside, what you can see is that this is going to provide power not only to the components, but also to the Arduino. So we talked about the HC-SR04, we talked about the button, the OLED, we have the first pin. We have the first pin when it is configured this way is SDA. So we have the SDA pin connected to the SDA pin on the Arduino. The SCK pin, sometimes it's SCK, sometimes it's SCL. The second pin is going to go to SCL on the Arduino. And then we have the third connected to the power rail. I don't want to have this power module on when I put the USB cable in, because the USB cable is going to be trying to power the Arduino, and then the power board is going to be trying to power it. If they're not exactly at the same voltage, it's like, I don't know that that's a problem, but in general, I don't like to apply power to the same point from two different things. And so I will turn the power board off, then I will download the code, and then after downloading the code and removing the USB cable, then I will turn the project on with this on-off switch. Okay, so I think I've kind of given you the highlights there. You can come and at your leisure, you can carefully look at this schematic and hook yours up, but hopefully you were able to follow along with me and get most of it hooked up already. Okay, so what have I done here? I have shown you kind of an overview of the schematic. I've shown you what my build looks like. Also, I kind of put a wire here to try to hold those jumper wires out of the way. And then also I kind of wired this around to try to get it to sort of stay onto the breadboard a little bit. So I'm trying to kind of get this where it'll be something that I could walk around with pretty easily. Okay, so that's what we're doing. I think now we are ready to come over to our code view, And I think this will give me a code view if I get this out of the way. And what are we going to do? We are going to open up a fresh new, bare minimum, a fresh new IDE, and we are ready to start coding. Okay, now I will come up here and we will start by importing our libraries. We're going to do an include, and we're going to include the SPI.H library, and rather unusually, no semicolon on includes. And then we are going to include the wire.h. Pay attention to case, capitalization is important. And then we are going to include the Adafruit underscore GFX .h, okay, and then we are going to include the Adafruit underscore SSD1306 .h, like that. Okay, now what you have to see is that these two libraries don't come with the standard IDE. You have to install them. I showed you how to install those in lesson number 52, but just real quickly here, you can search on Adafruit SSD 1306, and then you can see that I've got this library here, Adafruit SSD 1306. I've already installed it. I'm using 2.5.13. So you need to install that, and it'll ask you, do you want the dependencies? I always say yes, just give me the dependencies. And then you also need the GFX library, And let's see if that pops up. Yes, the Adafruit GFX library. I'm using 1.11.11. It's already installed. So if you've installed them already, you're good to go. If you haven't, you need to do that. I'm going to go ahead and compile this. And why am I going to compile it? I just want to make sure I'm going to compile it because I want to make sure that those libraries are loading right. So let's just do that real quick. Make sure everything is in proper order. It's looking pretty happy. It's looking pretty happy. Okay, so it is compiled, and we are now. Does it seem like this version 2X compiles much slower than the old 1.8? Okay, it is downloading and no errors and everything's good. All right, so now what we're going to do is we're going to come up here and we're going to set our pins up. And so we have the button pin, which I call butt pin, and that was pin 2 in that schematic. And then butt val, that is when you read the button, whether it has been pressed or not. And let me make this a 1, and I'll explain that. Okay, so the butt val, we're going to be reading from the button, but since we're using a pull-up resistor, if you are not pressing the button, it sees through the pull-up resistor 5 volts, so it's going to read 1. So I'm going to initialize this to 1 because that's what it should be when you turn it on. And then butt val old is, since the button hadn't been pressed when you first run the program, I'm going to also set that to 1. I just put these initial values so the program doesn't crash if you end up looking at one of them before you have made the read. Okay, so then I am going to go down and I'm going to, so that's the button. Now I'm going to try to set up the HC-SR04. So I'm going to say that I've got a trig pin, and the trig pin was pin 4. On the schematic, the echo pin was pin 3, and then we're going to be measuring ping time, right? The ultrasonic sensor sends out a ping and listens for it, and that amount of time for the ping to leave, hit the target, and come back, we call that what? Ping time, and we will measure that. And then also I want to float a targ distance. Okay, now Why do I make that a float? Because I'm going to get a ping time, and then I'm going to do a calculation. Distance is equal to rate times time, and therefore I'm going to calculate a distance. But if I'm doing in inches, I might want to see 3.5 inches or 12.23 inches. You see, I want to leave that a float. I don't want to round to the nearest inch. And then also, I'm going to fix this where I can just calculate the feet specifically, or yeah, in the feet, I'm going to make an integer, and you'll see why in a minute. But then the float of inches, so I'm going to have feet in inches. Now, what am I going to measure? I'm going to measure like 24.237 inches. Okay, now I can display that, but I also might want to display feet and inches. So how would I do that? Well, if I had 13.75 inches, that would be 1 foot and 1.75 inches. So foot needs to be an integer because I want to round it, and then the leftover part I will report in inches, and then I might have a fraction of an inch. So the foot is going to be a float, the foot is going to be an int, and the inch is going to be a float. Okay, now we need to set up our little OLED screen, and so I'm going to say the screen width is equal to 128 pixels, and then the screen height is going to be equal to 64 pixels, and then the OLED reset pin. Our OLED does not have a reset pin, but we need to set it to -1. That just kind of tells it doesn't have a reset pin. Okay, now I talked about this quite a bit in lesson number 53, but we need to give it the I2C address. So I am going to define, making this a constant, screen underscore address 0x3c. Now, it is very likely that this is the address, the I2C address of your OLED if you have this kit that I have. But sometimes there's identically marked little OLED screens that for some reason have a different address. So if you go back to lesson number 53, if this 0x3c, if it doesn't seem to find the OLED, I have a little program that I showed you how to use in lesson number 53 that will allow you to scan the I2C bus and to find the address of what you have connected. And so hopefully this will work for you. If it doesn't, I have some resources back in that earlier lesson. If you're just going to guess, if 3C doesn't work, 3D is a good address, and sometimes 78. Those two also sometimes work. But let's start with 3C, and then if it doesn't work, then you can just spend a little time playing around to find your address. Okay. Now we are going to create our OLED object. So I'm going to say Adafruit underscore SSD1306, which is our library OLED, which is the name of the object that we're creating. We're creating something that we're going to interact with the name OLED. And then what do we need to pass it? Screen width, screen height, and then we've got to send it the @wire parameter, because we are using the wire library. We have to pass that, and then we have to set that. We have to send it that OLED reset variable that we set. Then we don't forget the semicolon. That looks good. Now let's see where we are here. I think we have these things set up. I'm going to run this just to find my typos before we go on. This program's a little bit longer, and so I always like to kind of check for my typos as I'm going. Now, we can still have mistakes that aren't typos, but let's get the obvious ones out as we're going through it. Okay, that looks like it was happy. So we'll come down to the void setup. We might want to print something out, so I will say serial.begin, and we'll set it at 9600. I don't know if I print anything out or not, but I'll put that in just in case we need to do that for debugging. Now let's do our pin mode. So pin mode, what did we start with? The butt pin, and that is an input because we read from the button. And what did we need to do? We needed to activate the pull-up resistor. Very important. Now we're going to set up the ultrasonic sensor. We had a trig pin, and that was an output. And then we had a pin mode. We had an echo pin, and that was an input, right? We're going to do that pin in there, if you remember. Okay, now we need to turn on our OLED. So I'm going to do the OLED. That's the object that I created, .begin. Now we've got to tell it that this is just something that allows it to operate at the 5 volts, which we have connected it to. And so this is the command, get this perfectly, SSD1306 underscore switch cap VCC. Switch cap VCC. All right, now we've got to pass this some parameters as well. And what we need to do is we need to send it that screen underscore address, which we just set up, right? We just set that up, so that looks good. We're getting through this. Now, I don't know who used this thing last, and I don't know what is on the screen. So the first thing I want to do is clear the screen in case something is there from the last guy. Clear display, like that. That doesn't clear the screen, that clears the buffer. And now the cleared buffer I need to write to the screen, and I do that with the simple command OLED display like that, okay? Display like that. Now I think that I have everything hooked up. Yeah, that's looking good. Man, we're getting through this code pretty quickly, aren't we? Let's get rid of some of those blank lines there. All right, now we're going to come down here, and the first thing I'm going to do is I'm going to set up my screen, and I'm going to do a Control-T just to kind of clean things up. And I'm going to do an OLED.set cursor, and I want it at the X value of 0, and then I want to come over about 12. I want to be at the X value of 0. Yeah, I want to put it at 0, 12, and that way it's not exactly in the corner. It's not exactly in the corner. It comes down a little bit and makes it a little bit easier to read. Now I need to tell it that the set text, that is no good. Set text color, and it's going to be white, which on our screen will really be blue. But don't get excited and think you can set different colors. Basically, you've got white and black. White is on, black is off. Okay, OLED dot set text size, and we're going to set it to 1, which is small. All right. Now I'm going to start by printing on the screen a prompt for the user to point at the target and then press the go button. And so I am going to say OLED.println, and that is going to be point the, and remember, you don't get many letters on a line, so I got to break this up into different lines. Point the OLED.println. Remember, the ln takes you to the next line, so you don't have to set the cursor every time. Point the distomatic. You like that? I called mine the distomatic. I hope you guys came up with a good name for yours too. Point the distomatic at, and we better put our colons in here, point the distomatic at OLED.println target and press This is a little bit painful, isn't it? OLED.println and press go. Like that. So this should put a prompt on that little OLED of point the Distomatic at target and press go. All right. Now once we've done that, now that text is in the buffer, but what do we need to do? OLED.display. I can't tell you how many hours of my life I have wasted because I put things in the buffer and forget to write them. So don't forget this. Okay. Now let's see if that works. And so to do that, I'm going to go ahead and let's see if we can look here. This might come up upside down. Yeah, so let me flip it over this way. All right. So now, what did I say? Okay, let's go ahead and let's see if we can download this. Let me give you this view. All right. Yeah, that view will work. Let's go ahead and download. I like to find my errors as I go. You see? Echo pin, but that is an obvious one, right? Sometimes I don't get my finger off the shift key fast enough, but it's nice to just get these little errors out as we go. It's looking good this time. Okay, so what I got to show you is, now remember, I've got the power, I've got the thing connected here. So now what I'm going to do is I'm going to unplug that. And now with it unplugged, I'm going to turn the power on. And look at that. You see, we have got the point, the Distomatic at the target and press go. Okay, so we got that part working. I'm going to turn it off, and then I'm going to turn this back on. And I'm not saying this thing is going to blow up. I am not saying this thing is going to blow up if you run both of those, but I just think it's a good practice to not have them both powering this at the same time. All right, now we're ready to move on to the button. We are ready to move on to the button. So I'm going to make a reading from the button. But val is equal to, how do I do that? But val is equal to, I'm going to do a digital read on the butt pin. All right. Now remember, this is going to be a toggle switch. So you can go back and watch that toggle switch lesson earlier on if you're not familiar with how to use these little buttons. I have a whole class on that. But then now once I've done that, now I have a butt val. What I want to say is I want to know if I've pressed the button and released it. So when do I want to go? I want to go when the button goes down, nothing happens, but when the button comes up, then boom, the magic happens. So what would that be? Well, if but val equal, if but, man, what am I doing here? Okay. I got my parentheses off. And I'm in the wrong place here. You know, somehow I didn't go down to the void loop. So what I want to do is, yeah, I put this in the wrong place. So let me just get this, control copy. And then I want to make sure that I close my void setup, open void setup, close void setup. And I should have come down here. Right here. Okay, so now I'm going to do my read, and now if but val equal, if but val equal what? If but val equal 1, that means the button is not pressed. And but val old equal 0. Then what does that mean? Last time round, the button was down 0. This time round the loop, the button is up. That means I've had a button press and released. Then I am ready to go. Well, what will I do? I will do the things inside this open and close bracket here. Okay, so what's the first thing that I want to do? I want to find the target distance with the function that I will define soon of find distance, like that. So I'm going to have a function find distance, and it's going to return a number that is going to go into target distance. And did we set up target distance up here? Yeah, target distance is up here, so we're all good. Now, before I do anything else, I am going to come down and define that function. Now, let's be mindful of our curly brackets. This one opens the if statement, closes the if statement. This one closes the void loop. And so I'm going to come down here, and now I am going to do my function. So I'm going to return a float value, so it will be not a void, it will be a float because I'm returning a float value, and we called it find distance. Like that. We don't pass it anything. And then I open the function and close it. Now what do? I'm going to need a variable float d because that's the local variable I'll use to calculate distance. And now we're going to make the measurement with the HC-SR04. So we do a digital write. Go back to lesson number 52 if you want more details on this. But we got to put the trigger pin, trig pin, we have to put that low like that, and then digital write. Then we have to put the trig, and then we got a delay. I'm sorry, we need to delay in microseconds. We're going to delay in microseconds, 2 microseconds. Just give it a little time to make sure that we got a low signal. Then we're going to digital write. What are we going to write? The trig pin, and then we're going to go high. Okay, so now it is high. How long do we leave it high? 10 microseconds. Okay, and that will be 10, like that. And now we are going to digital write trig pin, and we're going to go back low. So what did we just do? We just created a 10 microsecond pulse, and that should launch the ping, right? That should launch the ping. Okay, now what we are going to do, now that we're low, we are going to measure the distance. And we do that by looking at the ping time, the ping travel time, which we get from pulse in of echo pin. Go back to that lesson if you want to understand this better. High. Okay. Now, the ping has to go to the target and back, but we want the distance to the target, so we need to take the to and back number and we need to divide it by 2, and I will put a 2 point to make sure that it does integer math. And then times, I derived this number using dimensional analysis the last time around. But what we're going to do is times it by 0.01. What is that nonsense? Hold on. Okay. What we are going to do is we are going to times that, multiply that ping travel time. The ping travel time is in microseconds, and if I want the answer to be in inches, I need to input the speed of sound in inches per microsecond, and we derived that in that last lesson and found it was 0.0135. And we're not going to rederive it, we're just going to do it because we did it last time. Okay, now that looks good. Echo pin high divided by 2. And now we are going to return D like that. Okay, we are going to return D like that. So now what have we done? We have written that function that we called here, and that value that is returned will go into the variable target distance there. Okay, man, we're cruising right along here. All right, let's see what we can do. What have we done so far? What have we done so far? We now have the target distance. Well, I want to know that target distance is going to be a floating point number in inches, so it would be like 13.75 inches. But I want feet inches. So what do I want? I want foot, and that's going to be targ distance divided by 12. Now, since foot was declared an integer, it is going to take 13.75 divided by 12. It's going to return 1, the rounded off integer number, which is exactly what we want, which is in feet. But now for inches, what we want is we're going to take the targ distance, which would be 13.75, and we want to subtract the foot that we just calculated times 12. So we calculated 1 foot, right? 1 foot times 12 is 12, and then targ distance was 13.75. 13.75 minus 12 is 1.75. So you see, it's like I'm getting the remainder here. This is getting the remainder. So the 12 inches went to 1 foot, and I'm left with 1.75 inches. And so it's going to say 1 foot, 1.75 inches. Brilliant, brilliant. Go back and listen to it again slow if it didn't make sense, all right? Okay, so now what we're ready to do is we're ready to put this on the display. So I'm going to say OLED.clear display, like that, clear display. That looks good. And then I'm going to do OLED.set cursor. This time I think I want it up in the left corner, so this is going to be an X value of 0, a Y value of 0. That will put the first letter in the upper left corner. Okay, now what I need to do is I need to say OLED.set text color of, and guys, it's not OUR, it's OR. Okay, sorry to offend our British friends, but OR. Okay, 0, 0, and then white, like that. So we've got our color, OLED.set text size. This time I want it to be more readable because it's just a smaller, it's like a number on one line and a number on another line, so I can make the text bigger to make it more readable. Okay, and now what am I going to print? I'm going to say serial. No, I'm not going to. I was thinking about printing it, but I'm not going to print it to the serial monitor. Hold on here. Let me get back. I'm trying to do a Control-T. Okay, now things are lined up nicely. Now what we're going to do is I'm going to do an OLED.println, and what I want to print is the string value of feet. Okay, so it would turn it would turn the number 1 foot. Wow, I hear a helicopter. I'm sorry, I'm easily distracted. Okay, I'm going to take string of foot, and therefore the number 1, if it was foot was 1 foot, would become if the number 1 foot would become the string 1. And then I'm going to concatenate that with a plus. I'm going to concatenate that with the string space FT period. So what have I just done? I've made the number 1 into the string 1 space FT, which is going to kind of have the units on it. Then I'm going to OLED print LN. Remember, the LN takes me to the next line, and this will be string of inches, okay, plus what? The string space IN period, like that. I think that looks good. What do you think? Okay, now what do we not forget? We've got it in the buffer, but we want to what? Display it on the screen so we don't forget that. And why does it make you do that? Because as you're building your screen, you don't want it coming piecemeal into the screen. You want to get it in the buffer and then boom, get the whole screen printed all at once. Hopefully that makes sense. Now I want to leave it on the screen for, let's say I want to leave it on there for 5 seconds. So I'll say 5,000, give the person time to read it. And then I want to clear it, OLED.clear display. And then OLED.display, like that, to display the cleared screen. Now, why do I do that? Because then we're going to go back up. We're going to go back up, and then we're going to prompt the guy to make another measurement. All right. So then that is all I need to do. And remember, this ends my if statement. So this is the if statement, and this ends the if statement. And then this one ends the void loop, but there's still one thing we need to do. Remember, we're reading that button. We need to tell it that but val old is equal to but val. So next time, this loop's but val will become the next time through the loop's but val old. And we've done that quite a few times, so hopefully that makes sense. Oh, I'm afraid to run this. How many mistakes did we make? But we've got the power is off, right? The power is off, and I've got the USB cable in, and so let's just run it to see if this will compile and download. So I'm sure I got some mistakes in there. Looks like I forgot a semicolon in there. Did you guys catch where I did that? What is this? Somehow I got something crazy here. What is this doing here? That probably belongs somewhere. I don't know how it got there. So up here, I say OLED set cursor, set text, print line, print line, print line, and then I have display. So probably at the start of the void loop, I'm going to go ahead I don't know where that, guys, where did that come from? So when I run it the first time, I clear it, right? When I run it the first time in the void setup, I clear it. And then here, when I get here, I don't need to clear it because it was cleared before it got here. I just build it and display it. And then here, I'm going to do a set cursor, and then I'm going to display it. And then I'm going to clear it here, so then the next time through the loop, it should be okay. All right, let me get all these lined up. Control T kind of helps you. Look at this one. I missed a semicolon there as well. Okay, Control T. I'm just looking this over. Okay, let's try this again. All right. But val old, I had an uppercase O for old. You know, this bumpy font where the first letter of each new word is uppercase. So let's try that. Now it's going to run, but like trig pin. Oh, TIG pin. Where is that TIG pin? That should be trig pin. Hopefully you guys caught that. All right. These are pretty small and easy to find errors so far. But just because it runs and compiles and downloads, okay, it's downloading. That's good. Okay, that is looking like it downloaded. And so what I'm going to do is I'm going to come over here and let's look at a view like this. Okay, let me see if I can, let's see. Let's just see if we can turn it on, what happens. Let's just see. So I'm going to take the power cord off. Now it's completely unpowered. Now I'm going to turn this one on, And let's see if we get something. Okay. What does it say? Point the distomatic at the target. Okay, so let's see if I put this here, and let me just see if I can roughly, we know this thing is pretty accurate, so I'm just going to put this here at 0, and then I'm going to put a target at about 7 inches and now I'm going to press the go button. And look at that. It says 0 foot and then a bunch of messed up stuff there. So yeah, somewhere I needed that clear display that I didn't get it. So you see, I was writing over, it was writing over the, what can I say? It was writing over the prompt. And so let's look at our prompt. So up here, we say, set the cursor, we do this, we do this, we do this, we do this, and then we display it. Well, after we display it, then we come down here and we display on top of it. So here, what I think I need to do is I need to do an OLED dot clear display. That's probably where that needed to go. So let's try that. Okay, and this time let's see if I can. Okay, that is going to run, I think. That is going to run. Let's see if I can set it like this, and let's see if we can kind of back off. That's kind of shiny. No device found. Okay. Remember now, what do I have to do? I have to turn this off and plug this back in. Okay. And now we need to download it again. Okay, I'm going to set this at about 0. And I'm going to set this at about 6 inches, but you cannot see the display. Okay, give me just a second here. Trying to get it where you can see the action, if you know what I mean. And so we've got that, and we've got that. Okay, now I'm going to unplug the USB. Behind me, I'm going to unplug the USB. I'm going to turn the power on. And now look at that. So we've got the prompt. Now I'm going to press the button and boom, look at that. It says 6.53 inches, which looks really, really good. Let's try that again. Look at that. All right, guys. Now, what I am going to do, I'm going to take this and I am going to point it towards the wall, and I'm going to make a measurement, and then I'm going to show you that that was 3 foot 5 inches. I'm going to point at this other wall, and I'm going to press, and then that tells me 3 foot 4.7 inches. So you see, I'm sort of like right in, and I lost my little wire here. Be patient. Let me see if I can get this wired back on here. Let me see if I can get this wired back. I'm trying. A rubber band would work better, but I didn't happen to have a rubber band. Okay, so. All right, well, we're just going to kind of have to hold it, right? So now I'm going to come over here again, point at that wall, and then what do I get? I get a 4 foot 4 inches. Now let's say that I point it back here behind me, and I get a 1 foot 7 inch, which really looks about, it looked about like 2 foot to me. And let's try it. Let's try it further from the wall. And this time we get a 2 foot and 9 inches. All right, guys. Man, do you see this? This is just really, really cool. This is just a really, really cool little project. And the thing that I would try to do is I would try to secure this Arduino a little bit more securely to the breadboard. And then I would also just try to get these wires run a little bit neater if I could. But man, this is just super neat. Look at that, 0 foot 4 inches. That is just absolutely on the nose. And I just think this is the coolest thing. Why? We are completely portable, right? I press the button and I look and I read 3 foot 11 inches right at 4 foot. So guys, wow, I think this is neat. So you see, we kind of started out, well, we're 53 lessons into this, but we started with little bitty baby steps, you know, how to light an LED, how to read a potentiometer. And now what we're doing is we're making prototypes that do real functions, that we do prototypes. We're making prototypes that do a real job. So guys, I hope you're having as much fun taking these classes as I am making them. As always, I want to give a shout out to you guys who are standing with me on Patreon. It is your Patreon support that allows me to create every single week fresh new content. I produce 2 new video lessons every single week. The only way I'm able to do that is because of you guys that are standing with me on Patreon. Thank you. You can also help me by giving this video a thumbs up. You can help by leaving a comment down below. If you haven't already, subscribe to the channel. When you do, make sure you ring that bell so that you get notification when future lessons drop. And most importantly, share this video with other people, because the world needs more people thinking like an engineer and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later. Wonder if we have any fishermen out there. I'm not seeing any fishermen today. I'm not seeing any fishermen. I'm sure they're there, but they're just not in my field of view. You guys like to check in on my corn crop. You can see the corn in the front yard. I have potatoes, I have corn, and then the far part is primarily rabbit food. Spider web. Okay. All right, guys, I will let you go. Look forward to seeing you next week. Paul McWhorter with TopTechBoy.com. I am signing off.